Righty-ho. Good evening. It's time for another Voron tuning live stream thing where we do stuff and things that we've not planned, just to finish off the build very gradually with all the little extra things that you have to do after you've kind of finished but not quite finished yet. So just so you know, parts for the build were provided by LDO Motors, OneTwo3D and BigTreeTech. So they technically sponsor, but it's not a paid sponsor thing. They just provided parts. But I'd recommend checking them out because they do lots of good stuff. Good evening, good evening, good evening, good evening, good evening to everyone. So I had a list before of things that I knew I needed to do to kind of finish it off. And I've lost the list. So I've just been spending the last couple of minutes trying to add some things to the list. So before we do anything, let's try and finish off or complete this list with other things that we need to do still. At the moment I've got input shaper, nozzle scrubbing. I've got the brush in there, I just need a macro thing to wipe it along. Travel speeds and homing speeds, at the moment they're really slow, so we just want to improve that. Tuning the first layer, kind of dialing that in. At the moment we've got an approximate one, but it definitely needs to improve. We're going to do maybe some print quality tuning with the Andrew Ellis guide that's on GitHub, and print a cauliflower for doing skew and dimensional accuracy. Other than that, I can't think of much else that we need to do. Let me know, what is it that still needs to get added to this list? Well, filament sensor is one for sure. There's probably more, but I can't think of what they are at the moment. What did we do last time? We did a bunch of tuning stuff. We got the RGBs and stuff sorted, didn't we? Input shaper, I definitely want to make sure I've got all the panels on. We've actually got some, I say we, I say that a lot, but it's me. I purchased some Noctua fans. They came in a box so large, I was like, oh, maybe there's two in each box. No, there's one. For some reason, they just seem to use the same size packaging for all their fans up to like 120mm, because I'm pretty sure this is the same size packaging I've had 120mm fans in. So that's going to be a thing. I don't know when we'll do that, but I might try and use the PWM feature of these fans as well. Not done that before, so that would be a complete gamble. Max speed using Alice's test speed macro. That one's on the list. Is that a filament sensor? Yes, so in the top right corner there, it's the BigTreeTech smart filament sensor is what they call it. So it detects, it like pulses every 7mm, and if it doesn't receive a pulse, it means the filament's stopped, so it knows then that there's a jam or lost filament or something. Yeah, so these are going to go in the skirt. Have you used the BigTreeTech smart filament sensor before? Mine is way too tight, so I'm currently testing a lighter spring. PETG is fine, but slippery filament like nylon under extrudes. Interesting. Make sure you do input shaper before finding max speed, so you know max acceleration beforehand. Okay. That's on there. I forget what else we need to do. Probably need to diagnose issues as well. I think there's still going to be this CAN bus issue. This is the thing that's on my mind, because while I did get a print out, it did seem to randomly connect and disconnect. So, what should we start with today? That's a real question. I think Input Shape is actually quite a good place to start, to be honest, because reasons. So, what I'm going to do ooh, we've not looked at it this way around before. That's weird. Okay, so we need the back panel, the bottom panel on, because Input Shaper is a frequency thing, and frequency changes with every tiny possible thing you could imagine. Not necessarily massively, but does have an impact. So that's the thing. Where's my bits? My bits and my bobs. I've lost all my... Oh, here they are. What data you rate? You're running the CAN bus on 250k baud rate. Do you really need preheat for input shaping? That does seem excessive. I suppose it would change vibrational modes, maybe a little bit. So not totally unreasonable, I suppose. Glad you've enjoyed the V2.4r2 video. We've got videos kind of lined up for a little bit now, so that's good. Hopefully I can keep it up. I find it really difficult, but hopefully we'll make it. C for science, that's a good idea. It'll also be a good loose screw detector. I remember that when I did it the first time, or when I like the first print, it like homed, and just as it started printing, like a screw just fell out. Because I'd obviously put maybe like 3 in or something at the same time, tightened 2 of them and just left 1 loose. Right. So that should make that nice and rigid down there. Oh, I do want to remove this spinny wibbly though. Spinny boy not needed for Can't remember which one of these is left and which one's right. They're sort of symmetrical, so it shouldn't matter, but one door. So that's that lot in. Do want to get filament engaged in here too. That doesn't feel right. I had problems including loss of connection at 250k and the Voron Discord consensus seems to be 500k. That's interesting. I wouldn't have thought it would make that much difference, would it? Obviously it does, but... Right. I can't remember how to change it though now. Bloody hell, doesn't that like... That's an entire reflash or something? Reconfigure or something? Not really familiar with CAN bus stuff yet. But I've done it obviously once. It's one of those things that's, especially when you do it on camera, you forget everything that you've done. I do anyway. I forget how awesome this printer looks. I've literally not turned it on since the last live stream. Look at that! Freaking awesome. So, let's try straight away. I'm going to do the input shaper first. If it doesn't work, then we'll start trying to do diagnosis. I don't want to try fixing things before they're broken, because then we don't know if we've actually improved anything. So... Can you also mount the LED light deflectors? Oh, the baffles I've not printed. These are still the old mounts and the old LEDs. I've not, I mean, they should be compatible. Pretty sure they are. But I haven't printed the new mounts. I printed them to test them that they work, but I printed them just like random green and glow in the dark filament. I've not printed them in black yet, which I need to do. I was going to do it before this stream because I want to get some photos with them installed. But the printer I was going to print them on is like just over here, and I didn't want like ABS fumes and stuff while I'm, you know, sitting here. So I think the first thing we need to do is check that it connects. We added all our temps. Look how many temperature sensors we've got. Oh dear. This is how warm it is in this room at the moment. 26 blooming degrees. It's absolutely ridiculous. We're going to do a cold cold run first, Alex, and then we'll try a warmer one afterwards. So first I want to make sure that we have ADXL configured. I don't know exactly how to check, but I'm going to just go here because I know it's on here. So here we go. We can see it's set up. We don't know that it's actually working yet. So "26 in my room's average, 28 in my room with no printers. 28 is hot. It's also super humid here today as well. Not that it's like a competition for who can get the warmest room. So I'm just looking, sorry, let's just put this on this screen so you can see what I'm looking at. The auto, I don't want to do this one. Pressure advance. Have I just found the wrong page? Measuring, oh, here we go. Clipper has built-in support for ADXL345. Auto-tune input shapers to compensate for resonance. Note that using ADXL345 requires some soldering and crimping. Wiring instructions, doobie-doobie-doobie-doobie-doo. Doobie-doobie-doobie-doo. Mounting accelerometer, doobie-doobie-doo. Resonance measurements and shaper auto-calibration require additional software dependencies not installed by default. First, on your Raspberry Pi, run the following commands. So let's go do this. So we need putty. And then we come over here, copy this lot, paste it in here. This should install the things that we need. I think we're competing for the hottest room. Thirteen would be nice. 13 with a nice jumper. 3 packages can be upgraded. Run apt list upgradable. Okay, I'm not too bothered. Did it run the... It didn't seem to run the second line. Already installed. Okay. In order to install NumPy in the Clipper environment, run the following command. A new release of pip available, 22.1, 22.2.1 to 22.2.2. To run update, run this. I think I had this on a different printer that I was working on just now, before, and I tried to run it, and then it just goes, no, can't do it. Okay, cool. Excellent. Depending on the performance of your CPU, it may take a lot of time, 10 to 20 minutes. Oh, well, mine was quite fast. Afterwards, check the following instructions in the Raspberry Pi microcontroller to set up the Linux MCU on the Raspberry Pi. I don't think we need to do this because we've got the secondary thing with the thingy thing. So I just start with one probe point in the middle of the print bed, slightly above it. Make sure the Linux I2C driver is enabled and the baud rate is set to 400K. Then add the following to the printer.cfg. Don't think we need to do that. I'm not sure, we'll check. Accelerometer query. Let's see if this is going to work. $76, 9.8, 0. Exactly 0 for Z. I guess there isn't a Z parameter for our accelerometer. I like how I mentioned the temperature once and now everyone's just like, energy prices, room temperatures. Forget the printers, let's talk about how warm our rooms are. I don't know what the humidity is here. I don't have... I live by the seas though, so it does get very humid. What is that temperature going up? The Raspberry Pi, of course it is. 51 degrees Celsius, a toasty boy. Okay, so weirdly, or concerningly, this is obviously gravitational acceleration. Oh, you can't really see because this is annoying. So this is acceleration due to gravity. This is one direction, and the other one's 0. Which is not good. Because that means y is actually z. Z is one of x or y. And the other direction is just broken. The seagulls are quiet. Maybe they're all tired as well. They've had a busy day of stealing people's food. This is definitely not going to work as it is. If you get an error where access some other ID, it is indicative of the connection problem or the faulty sensor. Double check the power, the wiring and soldering. There you go. That was one. Did you hear that? I wonder if because I got the printer going, the sensitivity of the mic is a bit different. I mean, I don't know why that command just doesn't even work. I suppose the other option is it's not configured correctly, but that would be weird. I don't think we'd get anything if that lot didn't work. Ah, the only thing is if these two are different. So we can axis map differently, because they're definitely not right. So what we actually have, the middle one is Z, so we'll change it to maybe XZY. Aha! And now it's working. I'm not sure how we can validate that the X or Y values are correct or not. Yeah, the axis map, that's the bit that's confusing me at the moment. I'm going to see if there's any suggestions in this for how to set that up. The accelerometer axis for each of the printer is X, Y, and Z axes. This may be useful if the accelerometer is mounted in an orientation that does not match the printer orientation. For example, one could set this to Y, X, Z to swap the X and Y axes. It's also possible to negate an axis if the accelerometer direction is reversed. The default is X, Y, Z. Turn the printer on its side. That's bloody genius. Kind of, anyway. It's inconvenient, but it's genius. Oh my god. These feet, they kind of like stick to the side. Okay. So we should now hit minus 9.8 for X. Okay. So it's minus X. I mean, I'm not going to worry about positive, negative, because negative acceleration is going to be the same as positive acceleration, doesn't really matter. It's just X, Y. X is the first one. Oh, that's correct then, isn't it? We have it right. Oof. What did it say for? Right, okay, some 40 sensor. Run. Just get some baseline numbers for the noise of the accelerometer on the axis. See, this is the weird thing. Why does measure axis noise not do anything? And it's broken again. And it's working again. And it's broken again. The fact that we keep going to random 0 tells me communication might be a little bit shit. Excuse my French. Command list? I had no idea this was here. Oh, yes, this is what I'm not having. So we're going to go in the middle of the bed, 50 up, 20 up, that's good. Yeah, sorry, me being a bit of a twit there. I do forget that you have to have these like text parts to enable different commands. It seems a little bit weird to me. Like it'd make more sense if you run the command and it's like, are you sure you want to run this? Because such and such resonance tester, for example, is not enabled in the firmware. Like then you can go put it in because it's telling you why it's not working. According to BigTreeTech, the mapping is XYZ. Yeah, apart from it isn't. Because if you... which is the one that was... So I want to query. And now... Shall we try this again? Yes, measure axis noise, there we go. So those are well below 100, that's fine. It'd be interesting to do multiples of them and see if it remains. Yep, we're good. Now you can run some real tests. So we can do them individually, or we can just go for the, oh, I suppose let's do it individually, let's do it the manual way. There's a big auto command, you can just run the whole thing and it creates all the graphs, but we're going to go through the commands. The slow method. I think it has to be homed first, yeah. Look how quickly that Raspberry Pi temperature dropped when the fans came on. I'm gonna, shall I bother with QG? No. And we're off. Doing the wibbly wobbly. There should be a good test of whether the connections and stuff are good to the CAN board as well, because I think if it's not, then it will cause problems pretty quickly. I mean, you can't really see much because, you know, the frequencies are quite high. Well, not that high, but the amplitude is very small. I'm interested to see when the PTFE stops. I suppose it's probably not going to, because it'll be lower frequency than this. There we go, that's the noise box level there. Whoa. I mean, ultimately, the desk that it's sitting on will have a big difference, and it's not going to be on this desk for very long, but I don't really have much of a choice. I need to be doing the filming. There's no point having a live stream when you can't even see what's going on. That's called a podcast. Ooh. That's the loose screw detector at 106-ish hertz. I think it goes up to 130 or something, doesn't it? 120. After this point, it's kind of gone quiet. There's not much doing vibration now. $133. Yeah. I knew that. Waiting for calculations. Resonance data written to this. Be sure to observe the printer for the first time to make sure vibrations do not become too violent. If vibrations do get too strong, you can attempt to specify lower defaults. If it works for X, run it for Y as well. Bibbidi bob boom. This is the extra noisy one because it's got more mass, I think. This is causing a lot of jiggering. Actually insane. It's going to be MVZ, MVZ. And it's going to be around 4.5 to 5K. Ooh, we're at the noise for the screw shaker, 104-ish hertz. There's a loose screw in there somewhere, I think. Oh, it's probably the bed, you know, because they're deliberately loose. Sounds like I'm making an excuse, but it's not, I promise. Why does it not want to focus on the actual stealth burner? 2 hump EI for Y. Oh. This will generate 2 CSV files. These can be processed with a standalone script on a Raspberry Pi. To do that, run the following commands. So we need to go back to our who. ZV at 57.6 hertz. $12K accelerations. This is the kicker. This is why. MZV 41 hertz. How was my guess? 5K. That was about what I said, wasn't it? 4.5 to 5K. That themeth correct. So now we go get the pretty graphs, and we can inspect them a little closer. Temp, shaper, calibrate. Here we go, these two. So we want 2.4 Livestream data, that's fine. Stick them in there. Close this. So this is X. In fact, maybe I can just split screen them. This is Y. Oh, it's not in the middle. So we've got a double peak here for Y, isn't that? Yeah. Don't know why, but we have. Can I post them in Discord? Not at the moment. I've added two-factor authentication, so it's logged me out of Discord on this computer. But I can later. Or did you want to see them now? You know what? This might be just because of the way it's mounted. Or it may just have, because this is not a very rigid mount. There's only like a couple of screws holding it in. It's a bit of a wobbly, flimsy thing. So it's like, it's fine for just holding the PCB, but it's not ideal, I guess, for doing this, where you're literally driving vibration through it. We've got a very big peak here, like 5 hertz. Ciao. So there's the graphs. It's just a configuration to be added to input shaper section of CFG. Can I just do a save thing or not? Do I have to do it manually? So let's get this graphs back. So frequency, recommended ZV, frequency 57.6, and type is ZV, and for Y, MZV 41.4. And then accelerations. This says max less than or equal to 5,000. I'm going to go for 4.5K. I know it says 4,000 here, but screw that. And of course with Clipper you only get one choice for acceleration. You can't split it between X and Y. So whichever one you have for X, you have to have for Y. Hi Nuno, good evening. I did put that under max acceleration, didn't I? Printer max accel. Yes. Choose some other configuration yourself. Bed swingers, max smoothing. Keep in mind that input shaper can create some smoothing in parts. Automatic tuning of the input shaper performed by calibrate shaper.py script or shaper calibrate command tries not to exacerbate the smoothing, but at the same time they try to minimize the resulting vibrations. The reported smoothing values are some abstract projected values. So the above shaper parameters are not bad, but what if you want to get less smoothing? Testing custom axes, input shaper auto calibration. So this would be the automatic one, which does all the things that I just did, basically. Nice. Bit of a lazy way to do it, maybe, but we could refine them if needs be. So we've done it cold. And then we could do it hot to find out if there's any difference. So what I want to do now is a preheat. Oh, do we have a? We don't have any calibrated or set up presets. What are presets? ABS extruder 240 bed 105. Let's do 110. Do we want anything else? Let's do all of them. 235, 85, PLA, 210, 60. That'll do for now. Yeah, I'm just trying to... There's so many bloody fans going on now. It's actually mental bananas. We've got filter fan, hot end fan, controller fans. Case light. So 20%, look how freaking bright it is. 3%. 8%. 8% is a nice sort of glow. 20% is... 51% is absolutely blinding. I think it's time to do a quick calibration cube, which is not going to be for any purpose of calibration, because of course we have the cauliflower for that. But it is a very quick print where we can check functionality. Oh, there's an annoying piece of ABS stuck in the middle of the bed. Do 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 do. Oh, so daisy. So we've got 2.4r2, ABS profile, calibration cube, a Voron cube. It's a teeny tiny. We don't need the extra strength for this. We're just going to go. I mean, to be honest, 2 perimeters would be plenty. Bending the heating bed is only if your heating per unit area is too high. You only need to turn it down if you're greater than about 4 kilowatts per meter squared. Otherwise you can run it at 100%. Oh, we could do the input shaper. That's a good idea. Should we do... Point 2.25 infill and top layers can be set to 0. Use 1 to 2 perimeters, or even better, the smooth vase. So should we do this then? Let's do this. Spiral vase. Is that what it wants? Smooth vase, spiral vase, yes. Bottom layers 5 times 0.2. Speed priority speed, external, the minimum layer time is at most 3 seconds. Make sure any dynamic acceleration control is disabled in the slicer. Yeah, I don't know if this is the thing that annoys me. I never know where these bloody things go. Not be emitted to G-code, so those accelerations don't go to G-code. See, this is what I don't want. I don't want any of these to go anywhere. If I put 0, oh there we go. I don't know why I didn't take it before. I can save it as a new profile in a second. Do not turn the model. Okay. We can save it as looks about right. Increase max accel to decel by issuing the following command. Disable pressure advance. I think that's already disabled. Oh no, it's not actually, is it? It's still got a little bit on. If you already had added input saver, execute set input shaper, frequency equals 0, y equals 0. Execute the command, tuning tower, set velocity, do. Basically, we try to make the ringing more pronounced by setting different large values for acceleration. Print the test model sliced with the suggested parameters. You can stop the print early if the ring is clearly visible and you see that acceleration gets too high for your printer. I mean, I was going to try and do a bed level thing to make sure the base is in the right place, but what, they don't all need to be. It's only doing external parameters pretty much. Internal and external parameters, that's the two that matter. They're both at 120. That's a good point. Let's check the preview. That's always a worthwhile endeavour. Yep. looks like 120. And then there's some 140 in there. Which is a flow rate of around 6 and a bit, 7. Why is there a random yellow line? Oh, that's a big fat base, isn't it? Jesus, okay. It's going to take a while to do all that. So this is where we can now check our temperatures for things like EBB control board, because this is not something we've been able to check before. At the moment, looking good, only 40 degrees, which is surprising considering its location. That location being slap bang in the middle of the hottest part of the printer. Nice to get some red LEDs going. We've got one red, one white for some reason. I feel like they're in the wrong order. I feel like the logo is meant to be white and the two by the nozzle are meant to be red or something. I don't know. I don't think you've missed anything yet. We're taking it slow, I guess you could say. We're going to do a print of the input shaper thing, so I've just run through the commands for that. So we've got chamber temperature 42, and interestingly the EBB 36 temperature is pretty close to the chamber temperature, which is odd. I would expect it to be higher. It's now lower than the chamber temperature. Something tells me that is not a very accurate temperature for that module. In fact, it looks like it would even be on the PCB and not on the MCU. I can't see a way that it's going to be cooler where the chamber temperature is than where the MCU is. Yeah, I would expect 60 to 70 for EBB in its location. 42 seems suspiciously cold, doesn't it? Come on, Pinder Probe, please work. I'm going to hide this one and this one, just because I don't think we really need to monitor those so much. Chamber I'm not so bothered about tracking. Yeah, I know travel speed and homing speed are things that are on my list of things to improve. This is the world's longest probing sequence. What are we doing? What are we doing? I don't know what's going on. Let's get that nozzle down a bit. We're doing it to measure. We've disabled the results. I was going to do a print anyway, so I was like, let's do, well, someone suggested this. But it does have a nice big first layer, so it's quite good for me to be able to tune that, and I think I'm happy with that now. That looks pretty tasty. It's so nice having clear side panels. I can look in from the side. This is a completely novel experience for me. God, they do get warm though. They need insulation, don't they? That is a buttery first layer. So, how much did I adjust first layer by? 0.025. Have you got foam tape on the panels or frame? No. What I did have, which is not necessarily going to work, but I got it a while ago as an idea and then never actually executed using it. Is some... it's like a reflective film that they use on windows as a heat reflector. So it's like it's a bit like a kind of one-way mirror looking thing. So you like put it on with like water and whatever, squeeze it out, and it just kind of sticks to the panel, and then it's kind of a thermal heat reflector. It won't work for conduction, but it will work for infrared. And it would look pretty bloody cool, I think. The amount of heat coming off this though, holy balls, Batman. Oh, this is not attached. Ah, now we relax while the printer does the printing. Frosted would be quite cool, but then you lose the ability to look through the side. EBB temp is up to 50 degrees, which is only 5 more than the chamber. Still managing some suspiciously low temperatures. I mean, it'd be nice if it really is that low. If it's doing such a small amount of processing that it generates barely any heat. I mean, I'm not complaining if that's the case, but oh, my computer's now got encoding overload errors. My computer was old last year, and now it's even older. Do you have a tool head fan? So there's not one for the EBB on the back, no. There's very little space back there. There's possibility with the, what do they call it? CB-C2 or something. It's like a cover with a little fan in it for covering the EBB board around the back of the stealth burner. clear side panels are nice to look at the print, but I have stuff either side of my printer anyway, so I can't see in the side. Well, yes, this is true. I mean, to be honest, after I've got this off the desk, I'm probably never going to look through the side either. At the very least, I'd have to move the printer out from wherever it's going to be. But it's just nice compared to the last one, which was completely dark, black, solid black plastic side panels. I couldn't see in the sides at all. I really overdid the solid layers on this. I think it's maybe a fraction over extruding as well, still. Do you have any news regarding the threaded insert heat press since the last Patreon post? I don't remember what the last Patreon post was. I can't share right this second. With an enclosure temp in the low 60s, you get EBB around 70. That's so, like, incredibly cool for a processor, isn't it? Literally a few degrees above the ambient temperature. It makes mine look about right. My chamber's now 48, which is pretty stonking warm, and the EBB is at 53.8. 5 degrees above ambient. That's insane. Because I had quite big concerns about using a CAN board in a printer, because like the whole reason we took printers and put enclosures in the base or outside or motors outside is so that we can make it warm without heating all the electrical processes, which will overheat in a hot environment. And then we go and stick a CAN board inside which got a microprocessor on which can overheat. So that's why we had all those wires and stuff through the umbilical and everything. Umbilical, drag chains, energy chains, whatever you want to call them. So that all we had in the printer was like basically kind of passive components. So by putting that CAN board in, I was like, this is like going against all the principles of keeping electronics cool. But it's never impossible for it to work. You obviously just have to make sure that it's designed appropriately, and as long as it's doing such a small, like, sipping power and doing barely anything, then it's obviously possible to allow it to work. Oh yeah, I can talk about the base. So, I mean, although nobody else here is, or there's very few Patreon people here probably. Tell you what. We'll have a little treat. So, seeing as this is printing, we'll talk about it. So, everyone, while that's printing, let's make this a little wider so you can see this box as well. So, since making this, which you can sort of see, and using it quite a lot for all my printing stuff, I've used it quite a lot, had lots of questions about it. I have actually mentioned once that I've been looking at making a kit, and along with that doing some design improvements and optimizations to allow me to kind of sell it as a kit, because it can be just a bit of a pain to source the right things, and people don't have like spare printer parts like I do, because you don't just get free printers that you don't want anymore. Hang on, I've just seen the... Have you had any issues with ooze nest filament trapping? I have a spool that traps the feed between filament and spool side every 50 meters. No, I've never had that. Yeah, the 2209 temperature is also a concern. This is true. Mine has a heatsink on, but again, in a really hot box like it's in. Is that enough? I don't know. So yeah, I've been working on a new version of this threaded insert heat press to use for a kit. So I can actually probably like literally build it now. It takes 30 seconds. Should we do that? Should we do that? See if I can remember how to build it. Do I have all the things in this box? I might do. No, I don't think I have the right bill of materials in the box. Oh, this looks like a bill of materials though. It looks like the print's starting, so I don't have much time to do this. So, the idea here is to make a kit of this thing. And I forget which way around this goes. So there's quite a few changes. So I've changed the design of most of the printed parts to either make them like easier to print or faster to print, or you know, like look a little bit better, look a bit more deliberate. Obviously if you were doing this properly you'd assemble it with the appropriate tools, but I'm just going to do it finger tight so we can do it nice and quick. Hopefully this will be done in time with me. I feel like it's a race now. So I've got 2 of these. I've also tried to minimize the part count and like the number of different parts, so you don't need like 6 different tools or whatever to assemble it. It's pretty quick and pretty easy to assemble. Can't remember if I'm supposed to put nuts on these or not, but I am at the moment. So the kit pricing is not fully confirmed yet, but it will go on pre-order fairly soon. Because there's quite a big amount of parts to, in order for this to work as a kit, I'll be doing it as like a batch order thing. So the first, I'll try and get like a big group. Maybe we'll do like 50 people or something, and those will be the first group, and then once we've got all those orders we'll buy all the parts to get it all done. And the plan would be that I'll be able to also sell printed parts, so I've got obviously printers around, so I can print all the parts needed to put everything together. Initially I'll probably only be providing one type of filament, one type of colour kind of thing, just because I don't want to overdo the number of variations or whatnot that I have to try and make, because that makes things complicated. I think we'll probably go with black. Let me know if I mean, pretty sure everyone would pretty much be happy with black. Yeah, I think the piece that I have here of the extrusion that I've had on mine is also 500mm. The one that's going to come with the kit is going to be 300mm, and I think that so while it's shorter, I've optimized the kind of travel and stuff, so you can get a little bit more length for your money, as it were. So it uses more of that extrusion in the travel movement. I think that's, I forget exactly where I need washer, because I'm trying to optimize it so I didn't have to like get more washers than I needed. See, that doesn't seem right, there's not much thread there. Oh, because I put this goes the other way, doesn't it? Of course it does. Do we have a washer here? Can't remember. It probably works, so we'll put one in. Oh, I think I've miscounted the number of M5. Oh no, M5 not here. Not expecting to do a speed assembly of this today. I have, oh no, there's the M5 nut. We didn't miscount. So everything is going to come basically ready to go. The belt will be cut to the length that you need and everything. So there's not too much messing about. The grips for the soldering irons is going to be difficult because obviously I don't know what soldering irons people have, exactly what the grip diameters and whatnot need to be. So there may be a little bit of trial and error at the start, but I'll be providing a big range of grip sizes. You just need to have a bit of a measure and tell me what size you need. And then they'll be available in ABS, so this is why I needed ABS printers and stuff to be able to. Yeah, there will be a no printed parts kit, so there'll be a hardware kit, there'll be a printed parts kit, as in, so there'll be a kit with only hardware, there'll be a kit with only the printed parts, and there'll be a kit that has the hardware and the printed parts. So that should cover everyone. I've also worked on this counterweight system as well to be a little bit easier. Obviously the motor was kind of, I mean, it was kind of just funny, to be honest, having a motor. I've not finished the design of this base yet, so. What was I saying? Oh yeah, the counterweight. So because you want to make sure that the weight's nice and balanced, because then you can control the speed that the soldering iron moves and the smoothness and all this kind of stuff. You need to be able to adjust for different weights of soldering irons, and it turns out they actually weigh quite a bit, and to overcome the friction of the V-slot wheels as well, you do need a fair bit of weight. Whilst obviously lead, for example, is a nice dense material, it's not necessarily good for actually using in a product. So we're using large washers. So I've got these like nice big M8 washers, like big flat round washers. They're quite cost effective. So you can use a bunch of them. I've left room in the design for you to add more if you need to. And it also means you can use it for other applications and stuff as well if you want to do that. You won't necessarily need all of the washers that you get with the kit, but there should be enough for everyone, regardless of what soldering iron you have, because I can't remember on the exact number, but there's like more than enough for most soldering irons, well, for my soldering iron, and I've worked on the assumption that other soldering irons will be very similar size. Yes, it's going to have to, because my design is based on my previous design, it will be staying open source. This grip, by the way, is in PLA. It's just geometry test. You will never have, well, I'm very unlikely. No, I'll never ship a PLA grip because it's just not useful. I didn't want to say never there, just in case, but because you never know what magic PLAs people are going to come up with. But so you probably notice I can assemble this pretty quick. Part of that is because a lot of the parts are like rotationally symmetric, so it doesn't matter which way round you assemble them. They work fine either way. So the 2 screws for this were not decided, I think, or the base ones weren't, so they're not included right here. Let me just grab 2 M5 screws. Whoop, whoop. So you need, I think it's 2mm and 3mm hex. I might change those, so don't grab that now, but that's what it is right this second. Just depends what exact screws I go with for the final published version. Oh, I've put the wrong screws in there, haven't I? Oh, I've assembled them backwards. Oh, what a numpty. I've done it a few times, but still not enough times. I've also got a washer stuck in between those two. How do I manage that? I knew I'd get it wrong when I rushed it. So for these, the V-slot wheels, you have to put the head on the back. Ooh. What did I shoot off this side there? Something. It's gone. And that's why there's extra washers, because they go on this side. Wouldn't we make it possible to make a grip that uses zip ties so it's universal for all soldering irons? Potentially. The thing about universal grips, or universal anything, is that it's always a compromise. As soon as you try and make it fit everything, it basically fits nothing well. And with parametric design features and 3D printers, I feel like it doesn't really make sense to do that. Oh, my counterweights are in the way. In addition to what you're seeing here, there's also a couple of end stops. So one of the comments I kept getting when I was using mine is, can you add an end stop? So if you're doing like 1,000 heat pressure things like manually for some reason, maybe not 1,000, but if you're doing a lot that are all like the same, can you put an end stop on so that they go the same depth every single time? And so I've added that as a feature. So there's just a very basic end stop. That means you can't overdo it. Seems like one could make an end stop with a T-nut and a screw. Yeah, that's basically what it is. Why isn't this going in? So I think these ones have a washer here. So 2 spare washers. No, it doesn't matter for now. There'll be like some assembly manual and stuff, so you don't have to just randomly do it from memory like I am now. As you can see, I've added this little dinky little handle at the top. And with this, so one of the improvements with the base you can see is that with mine I quite often ended up hitting against this, and there's a lot of like unusable space between this and here where you'd have the part to orient it. If you look at this one, all this space is open, so your parts can come right up below here. If you've got something that's quite large, you can get it nice and close to where this is moving up and down. So that's what it looks like. I'm really super happy with it. I've gone through a few iterations to get it just right. This is a 3D printed wrench to do the V-slot wheels. I'm probably not going to use it. It's not great. It's good for people that don't have anything else, but it isn't really fantastic. I've tried to work on the styling as well. Obviously the original one was very, I don't know, garage. Whereas I think this one looks a little bit more tidy. So obviously it's not got a soldering iron on it at the moment, so it's the counterbalance is too heavy. But so you can see this one, I've not tuned these V-wheels properly either. Hopefully you get the idea without me having to tune the whole thing. Hopefully you've got some nice metal spanners you can use. Oh, this one. You see, if it's too tight, it grips, but if it's too loose. This is probably about right with a soldering iron. So there you go. And then obviously if you did have like something extra you wanted to put on it, then you can just add counterweights, or you can just like literally take this off and add new ones. Hopefully, because I've just used standard washers, you should be able to find something similar pretty much anywhere in the world if you do want to add something different. So there you go. You can thank Balu there for asking about it. Now that I've shown it off, I think we'll probably get it on pre-order pretty sharpish on the website. As I said, it's going to be a kind of batch order because there's quite a lot of components. So it's quite expensive, even with, well, it's not expensive to buy a kit, but it's expensive to buy like 100 kits for obvious reasons. 100 of anything costs a lot. Does it have a cable guide? At the moment, no. So the reason is, A, everyone's got different cables. B, you don't really need it because it's very easy to just let it go off the side. C, you're not doing like 1,000 motions because it's a manual tool. You don't really need a drag chain or anything, and that just gets extortionately expensive for no real benefit. And if you clamp it to it, it ends up just kind of bending in ways and it can get trapped more than if you just leave it loose. So I found just leaving it loose is actually just as good as anything else. As it's going to be open source, you can obviously design mods and stuff for it at some other point. I think this print's ready now. The top handle should have a slot and zip tie holes for the cable. We could put some zip tie holes in there. As I said, it's not really beneficial. A spring on the bottom plate under the weight could be a good stopper. So we don't need a weight under here. So the stopper we have is up here. It doesn't, without the actual soldering iron, obviously your counterweight is way too heavy, which is why it makes the kind of sound. When you have a soldering iron mounted in here, it just goes kind of like this. It just goes slowly up and down. You just literally slightly tune the V-wheels until you get what you want and then leave it and it's fine. It just doesn't work well when you have a plastic one and you're not tightening the nuts properly. This tool is for, yeah, see, this gets a bit loose if you don't tighten it properly. For obvious reasons, tighten it properly. So this is the threaded insert heat press. You put a soldering iron in here, so it sticks out the bottom. You put your brass insert heated thing, and then you heat it up and you press it down, and it presses your brass threaded inserts into your printed parts. So like little inserts like these. The plan is it will come with a few soldering iron tips as well. So if you have standard soldering irons, then it will fit for M3, M4 and M5. That's the plan. Don't hold me to that. It will see. Make sure you read through the shop page for the exact final configurations. You really don't need a heavy base. It's literally, it makes sod all difference. Because it's a manual tool, you can guide it down anyway. Like, your hands are going to be here. You can have a heavy base. If you wanted to modify and put a heavy base, you can do that. But having now tried with a light base and a wooden base, which is a bit heavier but not that heavy, it makes basically no difference. All the time you're not using the tool, your counterweight is right at the base. Like, this is not going to fall over. I mean, you could, if you really wanted it to fall over, but I mean, if you put it down somewhere, it's not just going to randomly fall, because all your weight is in this bit down here, and while you're using it, and the counterweight is at the top, this is in your hand. And the only way this is going to go is down, because it's locked to these rails. And when it's properly balanced, because you've got a soldering iron in here, it doesn't fall at this rate of speed. It's much slower. Like, you really don't need a heavy base. It seems like you would, like a big, massive, heavy, flat, wide, but you really just don't need it. This is plenty stable as it is, in my opinion. Obviously, mod it to whatever you like. But from my perspective, this works excellently. And now it's got a little handle, so you can move it around without like randomly grabbing things like this. It's just boop. And it's really not that heavy. In terms of weight, somebody asked about the weight comparison between these and a stepper motor. So the motor I had, I think, was around 300 grams. So, I mean, you can add easily, I think, like 450 or 500 grams of steel on here if you wanted to. Like, you can get plenty of weight. And obviously with very small washers, you can tune this like to your heart's content. You can literally remove single washers until it's just right. And because it's got that thread pointing up, you could maybe put like 5 on, and as you're just starting to use it, if you think, oh, it needs another one, you just put one on, put a couple on, and after a while you think, oh yeah, that's probably about the right thing. You're like, okay, do that, take them off, put them on, and then it's permanently on there and they won't wobble anymore. It's just super duper neat. I was thinking of I might do it as like a video at some point. We'll make like an extortionately ridiculous expensive one that costs like 500 quid. Not to buy, just as like a demo super expensive overkill. Make it out of like a solid steel extrusion or something, just like gold plate it with like high wind linear rails and everything. It would be fun to do, but it's practically useless because this is not, it doesn't need to be a high precision machine. It's not a 3D printer, it's a hand tool. You're literally guiding it with your hand. So as soon as you've got that kind of inconsistency through being human, like precision goes out the window. You just don't need ridiculous things like that. Does it have resonance comp? Are you talking about the printer or this? So yeah, that's that. Let's get back to printery things. The website, I'm sure you know, is vector3d.co.uk. Will be up for pre-order pretty soon. I haven't got the price set in stone, but obviously I'm going to need to do that pretty quick now that I've started talking about it. In fact, that's going to be a job for tomorrow. I hate that my phone's basically broken. The sensor for pocket mode doesn't turn off. Look at that, perfect timing. High speed inserting. Yeah, I guess you can like add automation, you can add motors, you can add programming, but it adds to the cost, and in my opinion, like, it's a simple tool. It doesn't need to be more complicated than this. All the parts printed on that one are PLA. It can be PLA, obviously there's no real temperature requirements. PLA is pretty strong on its own. It doesn't need much, like even with like 2 perimeters and stuff, it can carry half a kilo on that counterweight, something like that. Because I've got it printed in a good orientation, so it's not like ripping layers apart. Oh, now you're gonna tell me I've used the wrong filament. Oh, before we do that, I do want to just quick check temperature graph. EBB, yeah, about 70 looks like. What? 68. Chamber temperature 52 and a bit. That was pretty consistent. Maybe still rising very slowly, but not much more. I'm going to need a glove for this. I'm happy that we've had no errors though. You lot talking about your 500k needed for it working. Seems to be okay so far. This is hot. The resonance is definitely showing. I think when I was using just like PLA a lot of the time, and I was just printing obviously pretty low temperatures, I would just handle it at 60 degrees and do it quick. But when you're printing at 110 or 115 or something, yeah, there ain't no speed in the world fast enough to stop you burning yourself at that temperature. You might notice as well, I mean, I've probably noticed it more than you have, but my nose is not going itchy and weird. The Raspberry Pi temperatures are going all over the place. That's a bit curious. Up, down, up, down, up, down. Not sure why. Hopefully you're okay in there, little Raspberry Pi. Save Z probe location. Oh, that's fantastic. You're going nose blind. No, I've got the activated carbon filter doing all the filtery things that filters do with filtering. I've been printing for many, many years. I think if I was going to go nose blind, that would have happened a long time ago. Nose blind. I've never had anybody call it nose blind. The question is, can you see it on camera? After the compression, you might not be able to. I can see it, but it's difficult to get the light in just the right. You can probably see it there, I think, is the best angle for here. That's the most you're going to be able to see, I think. Oh, I don't watch much TV. I only watch like Netflix. So that's probably why I've missed that. So, configuring or checking against what we found. This is not the page, is it? You can stop the printer earlier, use X and Y marks at the back of the model. The measurements from the side with X mark should be used for X-axis configuration. Measure the distance D in millimeters between several oscillations on the part with X mark near the notches, perfectly skipping the first oscillation or two. Preferably skipping the first oscillation or two to measure the distance between oscillations. Mark the oscillations first, then measure the distance between the marks. This is not easy. So what's that? 3. This is going to be very imprecise, I think. 8.16 divided by 3. Is V over N over D, where V is the velocity of the outer perimeter. So N over D. So V times N, so 120 times 3, divided by 8.16. 44. What did we actually get? $57. Not super accurate. No, the ringing on the test print should follow the pattern. Okay, I'm done with that. We printed the test print. I probably won't ever look at it again. Yeah. Now I've got auto-tune. Let's just auto-tune the dickens out of everything, eh? So we save that configuration. So I think that's reset all those temporary things I put in as well. Input shaper. Okay, cool. So now we want those travel speeds sorting out because they're obscenely slow. Maximum, maximum, maximum. How do we... Is that just the QGL thing? Points, horizontal move, Z. Can we put a speed for this? Points, speed. The speed in millimeters per second of non-probing moves during calibration. Default is 50. Yes. What do we call it? Speed. Yeah, 300 seems appropriate. It's pretty fast. I think we'll keep homing reasonably slow, but we can definitely go faster. Homing speed. I'm not sure what it is on the other one. Maybe we'll put that 80. That might be a bit ambitious. I am using end stops, but I'm not using end stops with levers. It's only the little plastic button. So we can tick off first layer, we can tick off travel and homing speeds. Let's give those a quick run. Oh, I've just realised I had the camera in the wrong place. Soz. Hello, Steve. Yes, all going well. I was a little bit concerned that our EBB BigTreeTech board was going to have some CAN issues because we had a couple of issues early on with that looked like they might be CAN related, but we've managed to go through input shaping and all sorts of other things. So, and we got lots of RGB now, so it's all happy days. We've just set up some faster homing speeds, so let's give those a go. Oh, I do like this camera. I'm going to find this super useful when I'm not sitting next to it anymore. Oh, it does look good, doesn't it? What a bloody terrific looking printer. I might have to change those idle LEDs to red instead of purple, but otherwise. Let's try homing. Boop. That's a little bit too slow, maybe on the Z. Isn't it Z Safe Home? Yeah, Z Safe Home, that's the one. Speed 100? That did not look like 100. Speed at which the toolhead is moved to the Z Safe Home coordinate. Okay, so that could be 300. Yeah, it's just a travel move. We'll put it to maybe 200. So help speed, move to previous, home XY, speed at which the toolhead is moved, Z harp. Distance. This is not the actual homing speed, is it? Oh, that's probably on the stepper, isn't it? Stepper Z. Homing speed 8. Let's try 10. Is that going to be okay? Can we go a bit faster? I don't want to smash the nozzle too hard, that's the thing. I think we can go a little bit faster on our X ones as well, X and Y. Let's try 100 this one, and 100 this one. How have I got so many updates? Bloomin' Nora. I suppose it does. It tells you about every tiny little like minor update. Is there a way to configure the update manager? It's maybe in is it in Moonraker config? I feel like I don't need to know about every minor update. Like if this 10.0 or 0.10.0 reaches like 10.1 or something, let me know. But I feel like this is going to be permanently on on an update mode. Yeah. I'm not going to do it now anyway. What one? I've forgotten what I was doing. Homing speeds. That's quite nice. I think we can still go faster. We might stick this to 120 even. I want to go a little bit past and then come back. Let's try 25. The camera I'm using, yes. I can't help much. It's one I found on AliExpress. It's an endoscope camera actually, as it happens. That's looking a bit nicer, isn't it? Speed wise, let's go. Try it again. Y is a little bit past there. You can hear it kind of hitting the end. I think Y will bring back to 100. I think that sounds pretty nice. Oh. So why is that so slow? Why is that so slow? What sets these movement speeds? Is this in here? Yes, let's move these. I like this. This is looking nicer. I'm not sure if you're managing to see quite what I'm doing, but you can. Just starting to move a little bit quicker. Well, if something's gone awry, I would hope not to be homing anyway. So we set those. Can we go? I feel like this is just disappointingly slow. Why does it? This feels like it's calibrated or set up for a lead screw printer. I feel like there isn't a reason why we can't go like 100 or 150 or something. Or am I just being stupid? Because it's a freaking belted Z. That doesn't sound like it's done it. Oh, are we hitting max speed for Z? Max Z velocity. Maximum 15 for 12 volt can increase for 24. Maximum Z velocity. Presumably millimeters a second. Oh, of course they are geared down, yeah. Well, let's see what this is going to do. Ooh, yep, and we're back. I always worry. After those issues with power and pi and stuff at the beginning, every time it turns off and back on, I'm like, oh, please turn back on, please turn back on. So I think I've changed my mind. Those are a little bit too fast, those X and Y. I think we'll take this back down to 100. And this is going to come back to like 90 maybe. That seems doable. Yeah, the step measures are not going too crazy. So that's just move speeds. So why is there? Oh. Okay, let's go and do this. Let's quick restart. Had a loose contact in my A motor wiring 2 weeks ago that shorted a phase in the stepper. I noticed it when my tool head round in the bed while homing. Oh, that's painful. I just hate that slow moving Z noise when it goes ah, ah. You have to move it faster so it doesn't make the annoying noises. Oh, now that's speedy. Oh, it's not that speedy, but it's nice and smooth speedy. The noise level difference between Z and XY is huge though. We're getting quite a lot of variation in this probe. So to only probe each point once for QGL and mesh. Derek Sorello, thank you very much for the $20. It's very kind of you. I've been catching up with the VODs. Thanks for the content. You're welcome. I don't know how to set it to only probe single points for QGL. Max adjust, retry tolerance. Yeah, I've already changed the tolerance a little bit. If I had home levers on the end stops, I'd probably home faster, but I can't with this setup. I think this is pretty good. A couple of rounds is not too bad for QGL, I think. We're hitting the tolerance in 2 rounds. Looks like we don't need a new board rate. You can change it from probe sample. Is that? That's not. Oh, it's this. 0.015, you reckon? 0.015 is very, very small, isn't it? We're not talking... And that's millimeters, so it's not tenths of a millimeter. That's 15/100ths of a millimeter. Yeah. Samples tolerance. Yeah, that's what I have for probe apparently. And you're saying put samples 1. I'd rather take samples faster than only take one sample. Is that speed going to allow me to take... of the z-axis when probing? Default's 5. It's on 10. Because I know the Prusa does this like beep, 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 zip, 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 zip. Instead of boo, it's so much more accurate when you make noises at the same time. So we can add in things to make this faster. So we can add lift speed, and we can put this at like 50 or 30. Yeah, the speed, so maybe I'll do, shall I go reduce this and put this on 1? Oh, 2. 8. Sample tolerance is insanely small. 0.01. See, this is, if it meets the samples tolerance, it's always going to meet the gantry level tolerance because it's the same. I think it's just more satisfying to see the printer go and like do its thing and not make those weird annoying noises where it's moving really slow. This is, and like, yeah, I want it to be precise, but I also don't want it to still take longer to do that than what I expect. I quite often, even now, will sit around printers. If I'm setting up like 3 or 4 prints at once, like on like multiple printers, I'll wait in the room until they're all kind of like started. Especially when they're kind of newish and not fully configured, or I'm testing new filaments, which is happening more at the moment. It just needs more looking at. So there, one of those, the homing down was good speed, because it was less noise, but after it had finished, it then just travelled up at this god-awful speed. I'm getting very passionate about the speed. It just makes a horrible vibration noise that's just unnecessary. That was very quick. Oh dear, no. Was So the homing parameters are on the steppers, which is kind of confusing, but sure. Enable pin rotation distance, micro steps, gear ratio, step pulse, pin, position, end stop, position max, homing speed 5, homing retract distance, you're right. X, Y, Z, homing speed. Homing retract, oh, homing retract distance. Homing retract speed. This could be different from here, which is, should be different from the homing speed, which is the default for this parameter. The default speed to use on the retract move after homing, in case this should be different from the homing speed, which is the default. But I don't think it is, because my homing speed is 25, which sounds nice, but this homing retract sounded horrible. We'll put it also at 25. Second homing speed, this needs to be nice and low. I feel like I should like nudge the motors a bit now that we've done it. Oh, not that much. Because otherwise the QGL is not going to get to actually do anything. This sounds nice. See, again, that was horrible. Did you hear it? There, fine. There, fine. Okay, okay. Horrible. It just ends with this. Stop making that noise. What is it? Second homing speed. Homing positive direction. If true, homing will cause the stepper to move to a positive. Homing speed. I wonder if there isn't. Is it just like a travel at the end? It's not that. That's not the... Because if I move Z now, it doesn't make that awful noise. Let's try QGL. So that time it had to do an adjust, which is good. You should always have a second loop. Always. You shouldn't always, but when you've literally deliberately jogged it. Oh, we're going for a third round. Lift speed. Lift speed, lift speed, lift speed. Where is lift speed? Speed of the Z-axis when lifting the probe between samples. In probe. But it's not even using the probe at that point. We can get rid of all of this. Oops. Oh, it's already here, lift speed 30. But no, it's not that, because this is the speed on the QGL, but it's not, it's on the homing. Moving Z5. No, I won't. It makes a good noise. Oh, that's moving 2.5. Oops. 15 to 20. To 25. To 30. This is nice noises. Max Z velocity. It's not max Z velocity because we know we're moving faster than it. It's moving too slow. And given that other commands are able to go faster, we know it can't be that. I think it's a default speed and it's always fixed. It's to do with homing. Right. Oh. Retract distance, stepper Y, Z. Homing speed, homing retract speed. Maybe. Oh, maybe it's in the macro, that's a good shout. It's after the home and it's doing a move. G-code, homie, G32, ready, levelly, quad gantry. No, that's... What was the... Oh, I guess it's like one of the built-in macros, I guess, isn't it? I think it's just not mapped to a variable. Second homing speed. No, that's so the second homing speed is so it comes down fast, and that's when it finds out approximately where it is. It goes back up, that speed's fine. It comes down really slow, but that's only 3 millimeters, which is what we want, and that gets a very precise indication of that end stop position. And then it's the final move. Once it knows exactly where the precise end stop is, it goes, which is just a move up like 10 millimeters after it's done. And I think that's after, I think it's part of the homing macro, whatever that G28 macro is. It tells it to do the things with whatever code it uses. And then after that, there's just like a move, and we can't set the speed of it. Unless I just can't find it, which is also very possible. Step X. Pin direction rotations, micro steps, gear ratio, pulse, pin, position, 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 position. Homing speed. So that's the speed at which it goes down. Homing retract distance is the distance it comes up after it's done a first home. Speed to use on the retract move after homing, in case this should be different from the homing speed, which it kind of does. It sounds like it's this parameter, but these, in my mind, these here are in order that they function. You have the homing speed, the homing retract speed and distance, the second homing speed, and it's after that. it's like the second homing retract speed, because it seems to be different from this. This one is fine, I think. See it as a noise, unacceptable, unacceptable. Are you all getting bored of me getting fussy about this? Is that what you're saying? We'll just accept that, shall we? 2.5 hours. We're basically done for the day anyway. Maximum speed calibration, you want to try that? Oh, I can't get the link though. Tell you what, I'm going to have to go like off camera to do it because I have to get stuff off my phone. I'll be back in a couple of minutes when I've signed into Discord and get this link. Okie dokie, hopefully that's all working again now. So if we look here, here and here and here, I don't know why it's kind of cropped off this, there we go. Determining maximum speed and acceleration. So this is Andrew Ellis 93's print tuning guide. The contents for determining maximum speed and acceleration. You can also use the speed for travels, but fast travels have significantly diminishing returns for overall print times, or just if you print speed into speed benches. It's also a bit of fun. 1.8 motors can generally reach higher top speeds or accelerations than 0.9 motors. For example, a 2 amp 0.9 LDO tops out around 450, and that should reach 800 to 1000. You may be able to get higher performance out of your motors by increasing currents, but be careful not to push them too high. You may also get higher maximum acceleration by utilizing Input Shaper, and may want to retune your max accelerations after tuning Input Shaper. Higher voltage systems, e.g. 24 versus 12, can also generally reach higher top speeds. Add this macro. Okay, so we're going to get that. That's a lot of macro right there. So we're going to go create file. Oh, there's a way to download this, isn't it? Save link as testspeed.cfg. It's also in all caps, so you know it's better. It's on page 2. We've got so many pages now. It's a shame that it's gone on to 2 pages when there's like anyway. If you have increased your max velocity, lower it back to the original value and reload. Max velocity. No, I think I kept it at 300. Ideally, the test should be run at the same temperature as your actual printing conditions. Oh, this is... It might show all... Ah, here we go. There we go. Cool. I'm also only doing it super large so you can all see what the hell's going on. It's just ridiculously sized for me. So it does want us to preheat. Ideally, the test should be run the test speed macro using the instructions below with increasing accelerations until you experience skipping. Start with a small number of iterations. Example, test speed, acceleration 5000, iterations 2. Once you experience skipping, back the acceleration down and try again until you no longer get any skipping. Once you have found a rough maximum, run the test again with a large number of iterations. This is essentially an extended torture test. If you experience any skipping during extended tests, back the speed down again. Use a slightly lower value than your results. Sometimes a maximum that works perfectly, even in extended torture tests, can skip during actual prints. Go a bit lower for a margin of safety. Save your new maximum acceleration and reload. Use the acceleration graphing calculator at the bottom of the page to find the theoretical maximum speed for your acceleration or print area. Remember it for the next step. There's only a theoretical maximum. I'll explain. I kind of wanted, where's the speeds? This is the one I got. Home, QGL, with you will reach what's... Check for minor skipping. Expect the G-code terminal output. Compare the numbers for the X and Y steppers for the first and second homing. These numbers represent the microstep position. What am I missing here? Why am I... Instructions below. Speed, acceleration, iterations, bound, small pattern size. Note that speed acceleration you input can override max velocity and max acceleration. Okay. To experience skipping, start with a small number of iterations. Okay, let's just wing it. I mean, carefully consider the correct options and then proceed cautiously. So we'll do something average to begin with. Well, that doesn't work. Oh, I need to include it probably, don't I? Oh, well that's clearly not what I want. It's a fucking HTML document. Ah. Test_speed. Presume I need to include it here. That's the normal, isn't it? Right. Time for some silliness. Chamber's at 40, that's not maximum, but it's not bad. So it's doing a home. Then we're doing a QGL. Oh, we've got a nice piece of oozy filament sticking out. Nope, it's going again. That piece of filament is really bugging me. Oh, how chill is that? This is like relaxing speed. I have a button on the screen for emergency stop, so I'm hoping that's going to be, I think it's done. 28954, 28970. So we did. Did we get skipping? What? The hole is not big enough for the tube. I might just do it tubeless. I have nowhere else to put the tube, though. I mean, I have access to the button. It's not far, sort of. So let's try. Thing is, it looks like it's skipping already, which seems odd. Micro skipping, as they call it. So we compare these, represent the micro step position, and saw that the difference between these numbers has not exceeded a full step. Okay, I'm running micro steps of 32. I would assume that the values for each axis have not changed by more than 32. If the number has deviated more than this, that means the corresponding axis is slightly skipped. .954. So that's 16. 9584. So that's 24. Right? So neither is bigger than 32. I don't have 48 volts, unfortunately. That was the plan originally, but it didn't work out. I may still give it another go, but it was a bit of a shock, let's say. Well, that was slow. The PTFE tube is flying all over the shop. It's definitely not going, the PTFE is not far enough down into that filament hole like it should be. I think it needs to be drilled out a bit so I can push the tube down. It's only in there like a couple of millimeters, so as soon as it moves, it all just comes out. Let's just come. PTFE can't get much shorter. Just going to get another piece of tube to see if I can actually find out why it's it's going like 2 millimeters in, and there's definitely a lot more room than that. Right, this is the thing. Do as I say and not as I do and all that. Much better. Hopefully I've not got plastic where I don't want it. That was painful to watch. It was painful to do. I didn't enjoy that process, but it needed to be done, and I didn't want to spend ages doing it. As long as we've not got extra filament all over the place, then we should be good. But now the PTFE is a little bit more secure, so we can go more send it. So I've not set a speed because it doesn't say to, so it's using 300 millimeters a second. I like how this bit is just really slow. I mean, my max acceleration is set to 4.5K, so we're not even going to be going this fast printing. Not this fast and not this much acceleration. Somewhat of a pointless exercise. Yeah. So I guess they only really need our printer limit at 4.5K is really just for the external perimeters, isn't it? I guess, and top layers, maybe bottom layers. That was 15K. It's really starting to move the desk. Uh, 959 from 968, that's barely anything. 593, 610, again, that's not a problem. So that's 16. So we jump up 2K, 18K acceleration. These big fat LDO motors are doing their job. That's that one. Let's jump to 22k then. Yes, they're 0.9 stepper motors on A and B. Okay, we'll do 1 iterations, and then we'll do more when we get higher, I guess. Good night, Lars. See you next time. What current are they at? I have actually not really checked, to be honest. Hopefully not too high. That's the one thing I haven't really configured, I guess, which I probably should have done first. Hopefully my motors are not like stupidly hot. Run current 0.8 for the X and Y. Well, that's just successfully done 22k. Oh, did I just do 2 again? Oops. I think for long term I'm going to keep it. They're only mounted to ABS Plus. They're not PCCF. I was going to, but I have not. I actually printed the mounts to do that, but I didn't end up using them. Why have I not done this before? Like, I should have done this, and I have not. I feel embarrassed. This is a good tuning process. I've never really done much tuning. I'm pretty lazy. Bloody mosquito. They're flying all over the room. I don't know why that weird accent came from. $29K. Are we on 35 micro steps? That's like 20, that's fine. 29K. $30K is danger zone for 2.5. Okay. Bibbidi bob bidoo bidoo bibbidi bobbidi boo. Oh, that 1 iteration. Okay, so we'll jump to 31K, but I'm going to go back to 2 iterations. Doo bidoo boo bidoo bidoo bidoo. I'm hoping the lack of chain on the X will give me a little bit extra acceleration capability compared to others. That was 31k. 958, 590, 20, that's still good. $33k. It's weird like this doesn't have just an incremental mode. That would be good. Like it does like 5k, 6, 7, 8, 9, it just goes up and up, maybe in 2k increments or something. And then you just run it until it fails, and then you know, rather than guessing like this. Absolutely stonks. I'm too careful to full send it. I don't want to break things. Don't break what you can't afford to replace, right? I can't afford one in the meantime. I definitely can't afford to fix it. I can feel, like, you know, you get that load angle where like the difference between where it's applying and where it's getting is slightly different. I feel like I can feel that. It feels different. Hopefully we'll hit 40k. I'm going for emergency stop instead of the power. I'd want to test this function. And I would never do it of my own free will, so it needs to be when I actually have to do it. Printer crashing would be louder than the sit-down. Yeah, I know, I got that. Don't worry about it. Hand on power switch. Okay, if I must. I told you it stops it. I knew it did. Why does it keep telling me I have to do an extra menu? The emergency restart on the front does work. There's an option in the settings that gives you a second check. I won't do it now because it's going to do a thing. I'll show you afterwards. In my mind, if the emergency stop does not emergency stop, it's not an emergency stop. It's a stop in a minute button. Holy shit bananas, this is 42k. This is mental. Full set 50k. Well, I'm basically there now. Okay, let me show you this. I think it was configuration on the actual screen itself. Configuration, settings, here, confirm emergency stop. That needs to be off. If you turn it on, that'll be when it goes, oh, are you sure you want to emergency stop? Turn it off and then it emergency stops. There you go. So many tips. I also want to put it back on temperature. That 50K, that 42K rather was cheating a bit. Oh, I hate how this camera is focusing on the door. Stop! I don't care about the door. Show me the printer. Okay, temperatures, are they coming back? Okay, we're pretty much there, right. Console. Hopefully we'll hit the limit soon. Should we go 45K? This is freaking easy mode. How's this? How's it doing so well? It doesn't show there. $100 acceleration. We'll find the limit first. 48K. Come on. We can make it to 50. This is still 300, so we're not going over 300 because that's like sensible printing speed, but we're just increasing the acceleration. So we're now at 50K acceleration. Speed is important because the amount of torque a motor can apply is dependent on its speed. If you increase the speed, you reduce the torque and acceleration. And while it looks like it's not going that fast when it's like going diagonals, I'm rarely going to be printing huge diagonals like that. It's normally going to be very small, so we'll be getting to our top speed very, very quickly. Micro steps, 11918, 11925, 4832, 4819. We're still within, like, this is getting silly. I want to find a limit. 55K. We must find a limit. It's got to be here. I thought you said 30K was the normal limit. It's getting to maximum speed basically instantly. How is this even possible? You should have just gone send it, full send it. Why didn't I full send it from the start? This takes too long. Oh! This is the problem with touchscreen. Just check the macro isn't broken with 100 acceleration. I accidentally, as I was going to be close to the button, I accidentally touched it. Ugh. Special LDO motors. I don't think they sent me anything extra special. It's just the normal motors. They just make good motors, it would appear. No, it's because it overrides max acceleration, supposedly. It does seem ridiculous that I'm hitting 60k though. I mean, I can feel it. Obviously, that acceleration is so rapid, it's imparting an enormous force. And I do feel it move the table, and it is getting harder. A harder force, stronger force. So... We're up to 60 freaking K. It's like it's being hit with a hammer each time it gets to a chorus, like bang, bang, bang. $33.97, that's within spec. 913, 90, that's within spec. So we're not skipping, and we've just done freaking 60k. How is this? How is this possible? Run 100 acceleration. Because you think it's broken. Whoa. look at the phenomenal performance. The homing is faster than the acceleration test. Are we still at temperature? I did reset it, didn't I? Yeah. Next to 100k. Well, we're climbing up on it. 65. I can't believe we're going to get much further. I feel like we're so close to the limit. It does seem absolutely insane, to the point where something can't be right. Maybe the speed is not really 300. Does this look like 300? Are we actually going like 150 or something? Are my steps per millimeter just totally wrong? This is bonkers. I feel like something cannot be right here, right? We need more speed. Well, if we increase the speed, it would definitely knock us down. Yeah, this is just an indicator. I appreciate that. It's not the full test. See you, Maker Man. Thanks for joining in. Hopefully you got those mounts that I released for the lights. Apparently I did build it very well, didn't I? I think it's very low friction. I managed to achieve really low friction on the assembly, on the motion of the gantry. There's something not right here. There's something not right. It was feeling great. Now it just feels ridiculous. It doesn't feel like it's getting more now. Do 100k. $100k. There's no way, surely. That was a limit. So it's somewhere between 85k and 100k. We did it, let's go. Right. I can't believe it, that's actually insane. Let's go down from there then, shall we? Down to 95k acceleration. Oh my god. Peasant level acceleration. Well, there's no point doing 110k because 100k doesn't work, so we now have to go downwards. But the fact that we hit an actual limit means that it's actually doing the thing that it's supposed to do. And there's me thinking 50k was a bit silly. Accelerations are over 90,000. Okay, somewhere between 85k and 95k. I will do a torture test when I find, we should find a successful one now on the way down. It should be this one or the one after. Well, we already did, didn't we do 85k? So, ooh, this is looking good. Ooh, that makes a horrible noise, that does. Okay, so maybe 80 to 85k regions looks to be where we're going. We did 175, not 85. So let's try 80k or 85k. It's actually not that loud. It's a really high-pitched squeal. The actual thud doesn't seem to be that bad. What was your setup then, Alex? Because if you've also got can board and umbilical, you should be getting similar results, right? Or did you have different motors or something? And I'll go down to 50k before it stops skipping. No, we know 75 works. This is looking good. Oh, that made a weird noise. I think that was some tiny skip. Oh, that's successful at 85k. Is it skipping? 95,350. 95,360, so that's 10, that's fine. 79,920, 79,934 is 14, so that's not. So there we go, 85 freaking K. That's insane. If you did it at 450, yeah, that would drop it a lot. So if I'll try 80k at 10 iterations. I do just want to take temperatures. Oh, we can do that. It's cold, it's cold. Why is it cold? Oh, because it keeps turning off. I don't know why we're heating up the extruder. That seems kind of pointless, doesn't it? Did you start from 10? I started from 5K. We started very pessimistically. Yeah, I need that 48 volts. I'm on 24 too, sadly. I can't, oh shit, we've done over nearly 3.5 hours. Yeah, fuck it, let's keep going. I'm enjoying this. I do need a quick break though. We'll be back in like a couple of minutes. Where we'll carry on doing some more testing. But as I said, quick break and then we'll be back. Right. Thanks to you, I changed my plan and ordered two 5160s and 48 volt power. Now I do have a couple of extra 22.9s. That thin tower vibe is a bit hard to find. Alex, are you running 2209s or 5160s? I wonder if that's the difference. I mean, speed is obvious thing as well. Yeah, I'm running. So I've got 5160s at 24 volts. I guess they shouldn't necessarily make a difference because it's the motor that's, I don't know. So, run the test again with a large number of iterations. So we should be hot now. Yep, okay. So now we'll go do our large number of iterations as our confirmed 80k 50 iterations. This could take a little while. I'm also at 0.8 amps. Can you try running it at 450 and 20k acceleration? Not now, because I'm doing this. I wonder if the 300mm speed is enough to get air over the heatsink for the extruder stepper driver. So, I mean, according to this guide, aren't I supposed to tune speed next? Save a new maximum acceleration to max excel in your config and reload. I thought max excel was supposed to be based on your input shaper. Use the acceleration graphic calculator at the bottom of the page here to find the theoretical maximum speed of your acceleration or print area. Remember it for the next step. This is only a theoretical maximum. I'll explain more in the next step. For example, a 300mm printer with a max of 3,500. Good evening, John. It's a shame it doesn't tell you how many iterations it's done. Because I haven't been counting. So my axis length is 300, acceleration is 80k. That's how quickly. Oh, you can't see. This is how quickly it gets to maximum speed. It's just like instantly there, fraction of a second, back down. So for the x-axis, I went umbilical because I saw somebody else do it and it looked interesting, basically. And with CAN, there's only 4 cables, so a big heavy drag chain, sort of not exactly needed. As long as you can still control strain on your cable a little bit. I think mine is a little bit long, unfortunately. It could be quite a bit shorter, but I didn't have much to base it on at the time. Oh, so I need that one, something. Shows that you can theoretically hit over. So our maximum theoretical speed is about 4,500 millimeters, so 4.5 meters per second. I mean, we're definitely not getting that, are we? What do you use to make that stiff? I used some 2.85 millimeter nylon filament. The problem with PTFE is it doesn't keep its stiffness. And because it's got a hollow internal core, unless you put something in it, it can deform quite easily. And once it's buckled, it kind of stays buckled. I can't believe this is still going. 50 iterations is a lot of iterations. At least our maximum speed, I don't think it's going to take very long to find. I could stop it. Why do you still have the y-axis drag chain? Because I got the XYN stops on that carriage, so there's 3 wires, I think. Isn't it 3? It has 4 pins. I think I'm only using 3 of them. But yeah, there's those there, so they've got to go somewhere, and I don't really want it umbilical from there, so we've got a drag chain for that one. What would be the preference is to mount the YN stop on the carriage at the back, not on the carriage rather, on the corner, the back right corner, and then use the XN stop on the carriage, and then we don't need that chain at all, and that takes a lot of weight off of Y, which is our limit for accelerations with input shaping. It's really satisfying watching the white text on the belts move around. Good evening, 3D Mamish. Thanks for joining us. Just go senseless. Could do. I'm attached to my old school end stops. Maybe I'll do that as well, and maybe we'll go back to trying out 48 volt power supply. Oh yeah, I forgot. It works best obviously when you've got, because it's sensing force in it. Oh, there we go, we did it. 80k acceleration, absolutely bonkers. Right. So, what we're doing, we've got to save that 80k. Into here. So now we're going to increment speed. Now I think this one might not take very long. This is Rapido, standard Rapido I think. Is the hot end fan fine? What do you mean by is it fine? Oh, I think, yeah, it's just frame rate. It's spinning properly. Once you've found a rough maximum, run the test again with a large number of iterations. Use a slightly lower value, save your new maximum. Use the acceleration graphic calculator at the bottom of your page to find a theoretical maximum. Blue line, repeat the process, this time increasing speeds rather than acceleration. Keep in mind that you can only go up to the theoretical maximum value you found in the previous step. This says do it at your current, so because acceleration being more important, I guess, is the thought process there. So we want 2 iterations, speed 320. You're right, I probably won't, but I'm going to try anyway. And then we'll decrease acceleration. But I want to see how high I can get. Starting to sound different already. One 1.4, that's good. 4 the speed to about. No, we'll make bigger jumps, I guess. But because we found the maximum for one speed, the maximum, if we're using the same maximum, increasing the speed, it will hit super fast. I know it. We're not going to get up to like 1,000. It's just not going to happen. Because that's not how stepper motors work. You have to compensate with one and the other. There you go. Oh, spicy boys. Yep. I don't have a temperature probey boy on them, but they are warm. Oh, yeah, that went weird. Console. What was the command for acceleration? Accel. So if we say acceleration at like 30k, the speed. What was the ones that you said? You had acceleration. Oh shit. Acceleration 20k at speed 450. I think that we can give that a go. That might be a good starting point. Oh, that's speedy boy. This is 300 size. 54 to 61, that's fine. 116 to 125. Ooh. Oh no, that's fine. Let's try 25k, shall we? Is the printer bolted to the table? No, it's not. But the feet, these rubber feet, are quite sticky, so it doesn't slide like a tool. Easy, mate, easy. We should be, in theory, I guess, near a limit here. So I'm just going to try increasing the speed a touch, a little bitty witty bit. That like exit, the little X it does in the middle is insane. Whoop. It's because I've got extra RGB. 653, 661 is okay. 115 to 127 is also okay. The feet that came with my kit are like suction cups, and once they've been on the bench for a while, the printer is hard to move. Yeah, so that's the type that I have on the original 2.4, but the newer ones, these are like a Trident feet. The same ones they use on Trident, so it's more like just a big solid block of rubber. Point at this one over here. And obviously it's got the little hole in the middle for the screw to go up through. Other than that, it's a pretty solid little block. So we failed there. Speed 490 at 25k. My computer is... this is a problem. Hang on. My computer's going to die because I'm recording this... Oh, that's not good. My computer's going to die because the stream is recording. Can I stop the recording? Yeah. The stream's recording, and the longer it gets, the more space it uses, obviously. Oh dear. A firmware restart may fix the issue. Something's going weird. What happened on that temperature? Oh, it's gone. I think it was as it was heating up, something went a bit squiff. So I think Clipper is attempting to start. The screen's gone a bit wibbly wobbly. There's not going to be one maximum, it's going to be a full curve, because every time you change acceleration, there'll be a new maximum speed. So what I was saying, before I interrupted myself, is that while this is obviously really useful, what it needs is a method to gradually increase accelerations and find the maximum speed at each of those accelerations. That will plot then a graph, and you just pick where on there you want to be. Like, good night, Sebastian. Thanks for joining in. Eddie the engineer made a Google sheet on it which calculates the curve of acceleration and speed for your motor and setup. Well, that's what we need, isn't it? That's exactly what we need. So instead then of doing every one, you do maybe 5 if it's a curve. And that'll get you something that looks like a curve, and then you pick where you want to be. But we've definitely learnt a lot about what the machine can achieve. It's pretty impressive. It depends how much we want on speed and how much we want on acceleration. And I think what you need then is your volumetric flow rate. So the max volumetric flow rate will limit how fast you can print, and that will then basically set your maximum speed with the volumetric flow rate that you want, and then you pick an acceleration that suits that. So if I try and draw up what I'm talking about, this is going to be difficult. So over here you have this and you have this. Can I? It's going to be a bit upside down. So for, say we put acceleration here, no, let's put speed here. This would be the 0, this would be like maybe 500. And they put acceleration here. So at low speeds, we get high acceleration, and then it maybe curves down something like this. That would be your like actual maximums. And then from there you find your safe limit, which is probably like somewhere just beneath it, like that, the blue line. And then you can find a volumetric flow rate from your hot end, and that will give you, based on, well actually based on different profiles. So volumetric flow rate is obviously a volume of filament, depending on your layer height, line widths, and the amount of plastic needed to move a certain distance. That will give you a different speed. So you might have, for like a 0.8 nozzle for maybe 0.8mm nozzle, you might be here. For like a 0.6 nozzle, you might be here. For like a 0.4 nozzle, you might be here. Obviously I've not put any units on there because it's kind of random. So that's kind of what we're trying to find. Does that make sense? Obviously you could adjust your 3 like profiles for different nozzles to all have the same volumetric flow rate and all have the same maximum speed, in which case you could just like say, well, I'm always going to print at this speed, so that's going to give me about this safe acceleration right here, and that's what I'm always going to use. So to say there is a maximum is not particularly accurate, but there's also a balance of acceleration and speed for different sizes of prints. So it covers the extrusion lines of the print in the fastest time. Yes, so the other balance is what would it be? You have your maybe average line length between maybe 0 and 300 for the size of my bed. So if like all of my prints were 300, every single line of that print would be going the full width of the bed. I mean, we've got diagonals as well, but let's just say 300 is the maximum length of line I can do. And then you've got here your like balance between 0, 1 of speed to acceleration. This explanation might not work quite so well. So if the average line length is really short, then acceleration is going to be super important. So that would put that maybe like here. Whereas as your line length gets longer, your average speed, or the importance of speed, increases. So you have like, I mean, it's probably not quite linear. Maybe it's like this or something. I don't know. So as the size of the print, the average line length that you're drawing changes, the importance of speed versus acceleration also changes. This is probably overly complicated and not as important as this. I'd say this is probably the main takeaway. You're measuring your blue line, you're finding with your different nozzles where you can sit on that print, on that curve, and adjusting your acceleration on your profiles to suit. Basically, yes, small lengths, small average length, high speed. I guess you could have like a speed curve, and then maybe it would do like this. And then here, this is where they're equally important. This is where speed is entirely important and acceleration is not very important. This is where speed is very important and acceleration is not important. Have I got that the right way around? It's weird having it upside down. TLDR, printer go fast. And of course we assembled this today without instructions and in record time. So some of you that have joined more recently, because I've been streaming for 4 hours now, might not have seen this earlier on. So this is going to be coming for pre-order really soon, because it was asked about and I was like, yeah, sure, let's do it. It's been pretty much ready to go for a little while. I was just waiting for the right time. So this is the threaded insert heat press tool. I really need a good name for it. That's what I need. Somebody suggest me some names. I have another product coming which I can't tell you the name of, but it's a really good name. They're like the Daylight on a Sticks have a really good name, and Daybreak has a really good name. Daybreak Neo, Daybreak Mini, like they all make sense. But this one I haven't got past like threaded insert heat press. Instead of 3000. It's just like a boring name, innit? Sorry, no offense, but I don't want a name that literally describes it, because that's what threaded insert heat press is. Names that describe things are generally not super rememberable, because if you remember the description of the thing, you just remember the thing. We need a really cool name for it. I think I did come up with some names. Where did I? Just looking through Discord. Hang on, back in a second. I think the best one we've come up with, V-Brass. It's not great. Sky Press sounds kind of cool actually, quite like that. It's kind of descriptive still. Definitely not a heat set insert press. He said he looks at face. The press and straight. That's very American, isn't it? Well, it is from my perspective. Insert press, yeah, it's descriptive again, isn't it? It's very difficult, I think, when you're like technically minded to have that creativity to use names that are not descriptive. Maybe something, because I'm just looking on the screen at it, and it looks kind of like a mechanical tree, sort of. The way it kind of has this like root system at the bottom, and these like arms are like branches. I wonder if I can like use that as a part of the naming. It looks like the SpaceX ship catcher. It's the catcher. Looks like a crane drinking water. So what would you name a crane that's drinking water? Greg. That's the one. Keep an eye on the website for pricing. I have an idea of what it is in my head. It depends, obviously, whether you want just the parts or you want the printed parts as well. I'm hoping, I mean, from my perspective, I think the overall thing is going to be quite good value. But I'm sure everyone will have their own opinions on that. Pulley press is, the name pulley is quite nice. The maker press is quite, exercise equipment, that's a nice way of putting it. Press ease. The easy press. This just sounds like a trouser press, doesn't it? I feel like we need to do like a competition on naming. Overkill heatset machine. Oh my god. Yeah, I mean, mine's basically made from end of 3 parts as well. But I realised that people were basically disassembling perfectly good 3D printers to build this insert press, and I was like, that really doesn't make sense, does it? My intention was like to use parts that everyone already had. But if you don't disassemble your printers... The Crane Zen water drinking toy. Oh, we could use some like Japanese... mechanical toy name. That sounds interesting. I could use my middle name. I'm going to hide your comment, John. It's been auto-flagged, but I appreciate the comment. I'm just not going to keep it public. Sorry. It's quite funny though. If you look in the bill of materials in the Excel document, well, it's Google Sheets document rather, in the description, one of the tabs in there has links for the mods. You should be able to find it in there, hopefully. I think I have an idea for a name. Zensert, that's quite nice. I do really like the design. I'm so chuffed with this. I spent ages doing lots of tiny little modifications. It's like, so let me show you one of the little design features, which is like, if nobody points it out, it's the kind of thing that you'll never even know. I'll put it in the instruction manual probably, but oh, no one. Unless you like do design and you think of the things, you wouldn't necessarily think that it even needs to be addressed. I really like that. So, oh, why is it? Oh, because I've got the bubble stop on. We can just do one. So, obviously, to hold these to this carriage, oh, that's not what. To hold the belt to the carriage is obviously just clamped with a screw through the back, and then you've got some teeth on this part here that just holds them together nice and tightly, while also not deforming either side. But I put this nice little slot in the back here, and you can see in there the end of the belt. Because I found if you don't have that hole, as you poke it in, you're not really sure exactly how far it is. Like, if you pushed it too far, like how many of those little teeth are you engaged on? Obviously you can like hold your finger against it and pull it out, and you have to like count them. It's like, is that too much? Is that too little? Have I done it too far? Have I done it too less? Whereas now you can like put it in and you have a look through the slot and you're like, yep, that's in the right place. Job done. The vector press. Yeah, so there's in the box I have got, I'm not sure, because obviously for the up stop you want a soft one, so rubber, which is what we've got, or just some soft plastic. Up here, obviously that's what you want when this reaches the top, just a soft stop. But when you go down, you don't want a soft stop, because that's going to then allow you to slightly change where that inset's going to end up. So I've got a solid piece. It attaches with the same screws in the same place, but this is solid. Well, it would be if I'd actually tighten this into place, but that's going to be a hard stop, and that's obviously as you pull down. So it'll go down, you're pushing, hit that, bosh, perfect position. You can obviously like slide it up and down if you don't need it, like maybe move it all the way to the bottom where it will basically have no effect once the soldering iron's sticking out here. I'm using V-slot wheels because nobody wants to buy an insert tool that costs like 150 quid. But yes, I'm thinking about trying to do a really Gucci one that's super expensive, but I'm going to need help with the pricing on that, because, well, it's not going to be a sold product probably, but I might do it as a special. But the nice thing about these is you can tune, oh, I forgot to put the carriage back on. You can tune the tightness really easily. Just slightly change the eccentric nut. Whereas with linear rails, you kind of get what you get, and it's a bit of a ball ache. I am on late tonight. I was having a lot of fun doing speed testing. I was meant to stop an hour and a bit ago. It's nearly midnight. But we built this, we tested this, we had a lot of fun. Stuff and things happened. And there's only even 35 people here. I think it's probably time to call it a day though, because I am quite tired. But it has been a lot of fun. So next time, what are we going to do? Volumetric flow. Just still printing in the background. What's wrong with my stealth burner lights? Do you think the colours are wrong? I think it's fine. Zensurds. They're red and white while leveling. I think they were white when printing. But yeah, I think just going, we'll just carry on finding that speed acceleration curve. Oh, sorry. I'm just yawning lots now. I should say goodbye before I just fall asleep right on the live stream. Thank you very much for joining in. Big thanks, Alex, for helping me through that tune-in. That was a really good suggestion, and it was a lot of fun. Yeah. I don't know when the next live stream will be. What day is it today? Wednesday? Won't be tomorrow. Might be Friday. It's a bank holiday Friday, so I might even reward myself with a day off. That would be quite the exception. But then I'd do this instead, which is still technically work. Oh, don't forget to go and watch the V0 video if you haven't already, because it's a bloody fantastic video. And a bloody fantastic printer as well. Thank you very much, everyone. I shall see you later. Goodbye. Check out the website. Pre-order one of these because they're going to be great. And I'll see you next time.